Next we have our last two exponent property rules. The first one is the quotient of powers property. That one says if you divide two powers that have the same base, you keep the same base and you subtract the exponents. Now, an example of why that might work, let's say, for example, you had 3 to the 4th over 3 squared, and use the definition of exponents. 3 to the 4th means 3 times 3 times 3 times 3. 3 squared means 3 times 3. You might remember simplifying fractions in elementary school, where if you had the same factor in the top and the bottom of a fraction, like you would do 3 divided by 3 and get 1, so we'd say essentially that they cancel out. When you're finished, you've got two factors of 3 left over, so using our definition of an exponent, that would be a 3 squared. And you can kind of see how the shortcut would work then, where you'd keep the same base, so you'd keep the 3, and the exponent would be the difference, or you would subtract those, 4 minus 2 to get the 2. And our last exponent rule is the power of a quotient property. Here you'd have a fraction raised to a power. Notice that this time the bases are different, and this one is almost like distributing again, where both the numerator and the denominator are going to get that exponent. So you have a to the m over b to the m. Now, an example of why this works out like this, let's say you had something like x divided by y quantity cubed. And we'll just use the definition of exponents, where when you cube something, it means you multiply it by itself 3 times. So it would be x over y times x over y times x over y. And then in elementary school, you might remember multiplying fractions, where you would multiply all of the numerators straight across the top. X times x would be your new numerator. And then you would do the same thing with the denominators. You would do y times y times y to get your new denominator, and then use our definitions of exponents again. X times x is x cubed, and y times y is y cubed. So you can see how it's almost like we can use that shortcut without doing all that writing, and we just cube the numerator and cube the denominator. Let's look at a few examples. So first we have 6 to the 5th over 6 to the 4th. That's an example of the quotient of powers property, where we keep the same base and we subtract the exponents. Remember, we usually don't write a first power, you would just write the factor without an exponent. Letter B is similar, except for now it's going to also add in an additional rule. First, it looks like the quotient of powers property, where we keep the same base and we subtract the exponents, but then that simplifies to y to the negative 2. And that uses a rule from the last video, the negative exponent rule. Remember, where that is where it moves to the opposite part of the fraction, so in this one it would move to the bottom of the fraction and become a positive exponent. Next we've got negative 3 cubed over negative 3 squared. And this is again the quotient of powers property, so we keep the same base and we subtract the exponents. And again, if you have something to the first power, we typically would not write that first power. All right, the next three are powers of quotients properties, where we said it's almost like distributing. So 2/3 quantity squared would be 2 squared over 3 squared. And these numbers are relatively small. You probably wouldn't even need a calculator, so go ahead and simplify those. 2 squared is 4, 3 squared is 9. All right, next we have another example where we're going to almost like distribute that exponent. So it becomes negative 3 cubed over y cubed. Negative 3 cubed means negative 3 times negative 3 times negative 3, which is negative 27. So then our final answer is negative 27 over y cubed. All right, and our last one here. This time the exponent that we are essentially distributing is the negative 3. So this would become 7 to the negative 3 over 4 to the negative 3. And then this is an example of our negative exponent property. Remember how we said it's sort of like it switches the part of the fraction. So the 7 that used to be in the top now goes to the bottom and becomes a positive exponent. The 4 that used to be on the bottom now goes to the top and becomes a positive exponent. You can leave your answer like that. I know I personally don't know 7 cubed in my head, but if you had a calculator handy, you could do 4 cubed and get 64, and you could do 7 cubed and get 343. So either of those would be correct.